Thank you very much. The context of this is when the federal government announced just before the recent COP, as soon as they announced the target of net zero by 2050, our phones started ringing not only from this sector but right across our business. What technology is available? What is Austen's doing about zero carbon, circular economy, renewable energy, zero waste? So there's some real momentum in this. We were already doing some work in the space, but the government announcements really put their foot in the accelerator. Just for context, I'm not going to spend any time on this. For those of you who don't know us, we're an engineering company and we do really fun engineering. We're a small family company, 10 engineers, tradesmen, so we design, build, and because we've got tradesmen, we actually make stuff. That's our market point. So we're smaller than the large engineering firms. Consulting firms talk a lot and write a lot of reports, don't do anything. Fabricators can make stuff, but they can't engineer. Standard equipment suppliers can't do bespoke equipment. So that's our little piece of the market. That's where all the fun is if you're an engineer like myself. Just an example of some of the stuff we do. This is the so we get customers walk in. Monash University walked in and said, "We've got funding for the National Drop Test Weight Facility. We want to throw 1.25 tonne mass at 20 metres a second at targets we're researching." And that was our design brief. So look at the left-hand one. So they've got high-speed cameras, and so they might spend a day building targets. But that's the sort of stuff we do. Someone walks in and says, we've got this thing, and we'll design it, engineer it, build it, make it. And this has got. I won't bother showing that next one. We've worked in this industry since the late 80s, so we do cremators, charge beers, coffin trolleys, catafalques, ash processors, grave shoring, grave safety fences, transfer vans, precast burial systems, whatever the industry comes up with. Catafalques, transfer vans, shutter handling. Okay, that's just the context. The three whys. Why hydrogen? Why are we doing this? And why you should think about doing this. So why hydrogen? Hydrogen is the most abundant element, and it's easy to produce. And there are alternative fuel gases you could use, and by no means I think will hydrogen be the only one. But hydrogen is it's abundant. It's easy to produce because it's just, inverted commas, just electrolysing water. We've got plenty of water. We've got plenty of power to do it. We can do it in an environmentally sustainable way. And it's a very it's a very energy dense fuel. You can see just on the very bottom there, if you can read it, 1 kilogram of hydrogen combusted is the equivalent of 3 kilograms of petrol. So it's very energy dense in terms of mass. It's not quite so energy dense in terms of volume. So hydrogen can be produced renewably as well. So electrolysis of water, and if you're using renewable energy for that, it's quite. You can then put your hand on your heart and say, yes, it is. Yes, it is green. There are other ways of doing it. Another one that we're working on is this second bottom one, which is actually pyrolysis, is hydrogen-rich, the gas that comes from that, and you can extract the gas hydrogen from pyrolysis. There are other ways that are less environmentally friendly. Why hydrogen in crematoria? Cremation needs flame temperatures. So cremation needs 800, 900, 1,000 degrees flame temperature. Electrical resistance elements don't cut the mustard at that. Electric resistance elements, 600, 650, maybe 700, will see you out. Someone will say, but there are electric cremators, and there are, and what they do is they heat them up as high as they can, and they're basically using the first couple of cremations to get the rest of that temperature, and then you need them to run 24 hours a day. So yeah, we need for cremation and a whole lot of other applications, we need flame temperatures. So we need a gas to put in some form of gas to put in our burners. Plasma technology is an option, and certainly our licensor did some work in plasma years ago. Potentially the problem with plasma is the temperatures are that high that you actually don't get any cremated remains out of them. The technology is that good that the calcium actually goes up in smoke as well. Both electric options use a lot of power, and they use a lot of power instantaneously. The electric cremators that I've seen, you literally had to ring up the power station and say that, well, I was turning on my cremator to heat it up. The hydrogen option or a gas option allows you to actually store energy, so you can have a modest electrical supply and store your energy in the form of hydrogen. There are other possibilities. So hydrogen is not the only answer, but it is one answer, and I think it's looking like a pretty good answer. And some of the other possibilities there, well, I've mentioned 24-hour operation and syngas produced from organics. Okay, why are we doing this? And for me, that's pretty important. There is no doubt that what we're doing at the minute is damaging. And if we're going to, I've got enough grey hair, and we've got kids. We hope to get grandkids. So that's really important. As I said, the phone started ringing for us, and I'm guessing the phone's going to start ringing for you guys. So we get pushed from our customers, and our customers are getting pushed from their consumers. State governments, the federal government's now got a 2050 target. The state government's got a 2030 target, and historically speaking, the low-hanging fruit is for governments to meet their targets is for their own departments and their own organisations that they've got control on, which are you guys. So it seems to me that it's highly likely that that you guys are going to get pressure, and the impression I've got from talking to a couple of people is that pressure's already started. Our prediction is that the governments will legislate, and we're already getting customers outside this sector, but we're already getting customers, in tender documents saying to us, what are your green credentials, Ostench? So, and I think that'll be indicative of what's going to happen down the track. So that's why we're doing it. The other one. So there was an article in The Age on last Saturday? There was an article in The Age last week where the article was actually about ExxonMobil complaining about the fact that the state government have actually mooted that they want to reduce the amount of gas coming out of Bass Strait by, and I don't quote me on this, read the article, I thought it said 25% by mid this decade and by 50% by 2030. And ExxonMobil, the article was saying that we argue if the government do that, we're going to be short of gas. So it seems to me that, and the government's only mooting it, the state government, but if in fact that is the case, there's an energy security issue for equipment that needs flame temperatures. So that's afterburners, certain sort of heat treatment furnaces, some melting furnaces, and included in that is cremation equipment. So why should you guys do this? There's obviously your own corporate responsibilities, and we've looked at everyone's website organisation. They all state, everyone's website here all states that they're going to be environmentally responsible, and this is a pretty significant way of doing it. You're getting pushed from your customers, you're getting pushed from governments. I reckon there'll be legislation changes and the business security. So. And the news for today, if you take nothing away from today, this is not difficult. I've got enough grey hair. I can remember town gas as a young kid. Town gas was pyrolysis of coal. You know, all of Victoria ran on town gas, so these big odometers, and there are still some around. Town gas was 50% hydrogen. You know, my old man's still alive, and we're a family business. He's going, "What are you guys worried about? You know, we've done all this. You know, the first step of this for us is first to get up to 50%. It's just dusting off my old man, and getting him out, getting his old textbooks out. It's not that hard." So what does green hydrogen look like? It looks really easy. So this is a setup in Jandakot in Western Australia. And the only reason, there's plenty of electrolyzers around. The reason I took the photo of this is my mate's the president of this company, and I was over there, and he said, "I'll come and see my electrolyzer." The white bullets there is the storage for the hydrogen. The blue one there is where they mix it with natural gas, and those boxes there are the electrolyzer. So and there are different designs of electrolyzers, and there's different technologies. They're basically in a container. Your shipping container, you bring in your shipping container, connect your leads up to it, and if you're buying green electricity, or you've got solar, or you've got both, you've then got clean, green, renewable hydrogen. The electrolysing on site is I think a good idea, because you're then not moving hydrogen around. You're not spending a heap of energy compressing the hydrogen, driving it around, and then depressurising it. If you produce your hydrogen on site, you can if you've got an electrolyser and you're plugged into green electricity, you can literally say, I'm going to start up my cremation furnaces at 9 o'clock, and you turn on your electrolyser at 8:30, and you know, you've just built up a bit of a buffer, and away you go. If you've got a solar installation, you might want enough storage for a couple of days. But if it's not much storage, and your usage patterns, you know, everyone here cremates during the day. The sun shines during the day, so there's a really nice match between producing it renewably on site and your usage patterns. So this is the same site at Jandakot. It's just an aerial shot, and they've put 150 kilowatts on their roof. And this particular company actually runs, that's my mate turning on the gas. This particular site, I thought I had a slide in there of it. Yeah, this particular site actually uses their hydrogen, and they've got a fleet of 6 Toyota Mirrors, and they run, and these Toyota Mirrors are a hydrogen fuel cell car, got a range of about 500 kilometres. They go like shit out of Shanghai. Fantastic. And so they run all their fleet cars on hydrogen, and 150 kilowatts was enough to run enough to run their cars. So this is not only applicable to cremation. Once you set up this, you can then roll it out across your business. There are, I understand, and I think it's JCB, but don't quote me, that are already starting to trial excavators running on hydrogen. Yep. Okay. So. And again, the burner technology is not that hard. There's a whole lot of companies now, you know, people that supply gas valves and regulators and pressure switches and burner nozzles and all that sort of stuff. A lot of that's a lot of stuff we buy is from Europe. They've done all that work. You know, you can actually pick up a catalogue and they'll say, you know, this particular valve is approved for hydrogen. That's what it looks like. 100% natural gas. And then increasing ratios up to 100% hydrogen, similar flame lengths, slightly different flame speeds, but again, from an engineering point of view, that's a matter of us tweaking. Okay, all right. So we've been lucky enough. Lynette did a great job finding a DELP grant for, and what was it about, Net? It was for demonstrating the use of hydrogen or something like that. So we put in a grant submission, Ashes to Ashes hydrogen for cremation, and DELP loved it, and we got a grant. So this grant, amongst other things, is us putting up a demo burner running on hydrogen. So we're going to get some gas bottles, you know, pipes, valves. We're talking with ESV, Energy Safe Victoria, about approvals. There's not legislation in Victoria written about it. They've come down and seen us and said, we want to work with you to make this work, to get the, and they'll review our submission, they'll bless our submission, so we'll get regulatory approval for it. So we're not doing it behind behind closed doors. And the idea of the regulatory approval is we can then roll it out, and that's part of the grant that we're getting is we've got to do that. But then part of the grant is sharing the knowledge, which is part of what we're trying to do today. So we're actually going to set up a demo burner to demystify the whole enchilada. So anyone here can come down, bring your boards down, whatever, say this is what it looks like. That's the gas bottle, that's the pipes, that's the button you press, and you get a flame out there, and away you go. We're doing it. The demo we're setting up, what we hope to do is show that with existing gas trains. So we've got customers all over the country. There's obviously a lot of assets sitting there. We want to be able to show that the existing assets with either minimal or no changes can run on a certain percentage of gas. That'll then enable our customers to do a few things. One is put their hand on their heart and say we're starting the journey down renewables. The second one is that that'll establish their supply chains and get all that organised, demystify it for operators, and as I said, they can go to their market. We got great support from the industry, and especially from the Geelong Cemeteries Trust. They're actually a partner, so we really we do thank the organisation for the industry for the support we've got. We're an enabler in this, so we're not generating the hydrogen. But as soon as this was announced, we had our phone went off the hook. Not quite. We had a lot of phone calls with potential suppliers saying, "Gee, we want to talk to you." All of a sudden, we've got someone that's an enabler in the middle. So they want to hook up. They want to hook up with us, and they want to give some presentations. So there are suppliers out there that are keen to supply this. So we're trying to start an ecosystem. There's already been trials done in Adelaide, I think in Tonsley, where they've actually a little neighbourhood. They've put in 10% hydrogen into the blend, and this is for domestic appliances. And they took surveys. 10% hydrogen seems to be a bit of a no-brainer. What we want to demonstrate and show is we can push that up. We want to find out how far we can go with our existing gas trains, and then what changes we need to make to our gas trains to go further. Obviously, some of the resistance, there's not even resistance, some of the hesitation by our customers is they're going, what does this look like? What's our business interruption risk? And again, what we're going to do is show that, and we're also going to show that if the hydrogen truck doesn't turn up, or the electrolyser breaks down, or one of 50 things, that you will have no business interruption. You'll still be able to run on natural gas, and natural gas. We'll show that at the demo. We'll run it on hydrogen. We'll turn off the hydrogen. The burner will keep running. And obviously, by doing this, we're going to encourage a supply chain, and we want to encourage early adopters. So what does it possibly look like? So we think the low-hanging fruit is to convert your existing equipment, or if existing equipment's up for replacement, new equipment, to run on a blend of hydrogen and gas. Right? That's the low-hanging fruit. Then you set up your supply chain. Now, whether that's buying green hydrogen and bringing it in on a truck is a possibility. Initially, it might even be buying hydrogen that's not green just to get started. But possibly set up your electrolyzers, set up your solar. So you've then got a visible demonstration of, here I'm producing it, here I'm using it, and then when you've got that set up and everyone's organised, it's then possible to increase the blend, and then the final step is the 100% conversion. Where we're up to at the minute, we've got to have this grant. One of the conditions of the grant, and this shows you how seriously the government's taken. One of the conditions of our grant was we have to have this finished by. They've been a bit late delaying, but we had to have it finished by 30 June. We'll get an extension, but it won't go any further than August or September. So we've got to have this running. So this will be ready all going well, will be actually ready to roll out by the end of the year. So that's the end of the hydrogen. I just wanted to quickly talk about one other very high carbon footprint, which I've been approached by a couple of trusts already and other customers, is concrete. Concrete is probably your biggest CO2 emitter, and there's a whole lot of really good work being done on reducing that. And John at the back's done some fantastic work in that space, but it still has a footprint. The other technology we're working with is with Rockler, and this is geopolymer. So this technology's got no concrete anywhere near it. The actual binder system is in our chemistry, and there's different forms of chemistry. In our chemistry is fly ash and caustic. So it's still sand and stone, although the sand, we want to do some work on replacing sand with recycled glass. But it's using waste product. It's got an incredibly small greenhouse footprint, so you don't eliminate your footprint completely because there's still some embedded energy in crushing stone and this sort of thing. But it's an incredibly small footprint. It's a very well-known technology, as the slide says there. The Romans used it at the 2,000 years ago. Their source of alumina silicate was a different source, was clay, but and this product's acid resistant, salt resistant, caustic resistant, thermally stable at 700 degrees. So it's actually a better, in some engineering senses, it's got better properties than concrete, and it's got an incredibly small greenhouse footprint. That's the key. Our technology, we're using glass fibre rods instead of steel, and the glass fibre rods have actually got, again, less embedded energy, but the big thing is that they're completely immune to concrete cancer. They don't rust. And we've just recently completed a project for the City of Greater Geelong, so 2 pedestrian bridges. Their requirement was 100 years maintenance free, so they don't have to be painted, scrubbed, washed, anything. They're thermally stable at 750 degrees. The previous bridges the vandals burnt, or timber bridges, the vandals that actually burnt them. The vandals can come along here and light a fire under that and it'll be pristine. So this is another option for reducing your greenhouse footprint as well. And those two combined probably make up most of your, and the third one would be transport, but those two combined would make up the bulk of your CO2. The transport, obviously, you can address partly by hydrogen and obviously partly by EVs. So the solutions, I'm an engineer. The solutions are there. We've just got to implement them. Which we're doing at Austinge. We're virtually electrically completely neutral now, and we've now got 4 vehicles that are electric. So we're going down that journey pretty rapidly to show that it can be done. So yeah, I'm on a bit of a soapbox as well. But the engineering, but the thing is with the engineering, the reason I started out with that is that the engineering's out there and it can be done and it can be implemented, pretty quickly if you want to. So any questions? That was a pretty quick run through given we had a late start.
Have you any idea what it would cost to implement a partial hydrogen fuel to an existing cremator? Obviously there's going to be a pressure vessel where you'll unload to, you'll have a mixing valve,
Yep.
Mix in with your normal gas. Have you any idea of what that would cost to set up, please?
Yeah, thank you. I've got no feel for the cost of the electrolyzers, but but coming out of the electrolyzer, if you had a source of hydrogen, we're talking about some gas valves, some pipes. You've got to store it in a different way. Hydrogen, natural gas is heavier than air, so a lot of the ventilation is all about draining. If you get a gas leak, draining it out. Hydrogen floats, so the ventilation is different. I think the short answer to your question, John, is a few tens of thousands of dollars. We haven't got accurate numbers yet, but it's not a significant amount. The biggest cost is actually going to be in the electrolyzer itself, or buying the hydrogen bottles.
And suppliers that are running around now with trucks that will discharge into the receiver?
So the short answer is Air Liquide and BOC are both have both contacted us, and they have that. Have they got much infrastructure? No. The dilemma is at the minute is that all these people are sitting there going, "Gee, I'd do a hell of a lot if I had someone that'd buy it," and then the other side's going, "Shit, I don't want to convert my equipment unless I can get a supply." So what we're trying to do with the blend is de-risk it for both sides and say, okay, put that in, you can have a blend there. If the truck doesn't turn up, the electrolyser doesn't work, whatever, you've got no business risk, but you do establish a supply chain, so all of a sudden you can start going to these people and go, you know, we are going to use this much, you know, we know we do this number of cremations a day, we use this much gas at the minute, we've got this percentage, we will guarantee you an order for this much per day, every day. And these companies are just begging to get started.
And last question, have you any idea of the comparison of price using hydrogen as a mix up to the 50% as opposed to using traditional gas?
Yeah, and the short answer is I don't have an exact number. Is it going to be more expensive in the short term? Absolutely guaranteed. Yeah, it won't. You'll notice I deliberately didn't put up there, this is going to save you money. In the early stages, yeah, no way. Because you know this whole technology, as a whole lot of environmental technologies, will follow Moore's law, and Moore's law says that, and we've seen it with TVs, and we've seen it with solar panels, and we've seen it with computers, and we've seen it with cars. You know, Moore's law says that the performance will double and the price will halve every 2 years, and that's what we'll see with productions of hydrogen and of electrolyzers and all this sort of thing. You know, you need early adopters. You need early adopters coming on board to establish supply chains, so you can then start getting volumes and you can start getting prices. One of the advantages of initially a blend, even if the hydrogen, pull a figure out of my head, is twice as expensive per kilojoule, if you're only blending 20%, your total cost won't go up that much, but it will have the effect of A, saying I'm doing something, B, establishing supply chains, and C, demystifying it.
Ross, with your electrolyser, I guess if you're making hydrogen on site with an electrolyser, how much can you store and what's the safety level of that kind of storage?
So look, how much can you store? As much as you like. The Dangerous Goods Act, you know, which governs, you know, the dieseline you store, and the natural and the gas the LPG you might store, and all the rest of it. So there's certain thresholds, and above, you know, up to a certain threshold, there's not too many requirements, and then above that you've got to bund it, and then above that you've got to, you know, so it goes on. So there's no sort of limit on how much you can store. To me, and how much you'd store would depend on how you produced your hydrogen. If you had an electrolyser on site and it was plugged into the grid, and you were buying renewable power, for instance, you don't need to store much at all. You know, a bottle the size of that cylinder you saw in there, you know, which is the size of an LPG cylinder, would be any amount enough. If you were trying to do it off all of solar, you'd have to say, well, I've got to account for 3 cloudy days, or, you know, or something like that. You know, do some survey. So in that situation, you'd be storing more. So that'd be a site-by-site sort of analysis of, you know, how much am I cremating? You know, if I didn't fire up for a day, would that be a problem? If the answer to that's yes, it'd be more storage. You know, so on and so on and so on.
I was just going to ask. This is probably an obvious question, but the difference between green hydrogen and hydrogen is just the power source used.
Yep. Yeah, that's right. Yeah, green hydrogen's renewable, yellow hydrogen's done by nuclear, brown hydrogen's gas. I forget them all. There's turquoise hydrogen is from pyrolysis.
And how much power does your electrolyser draw? Like, could you store power in a battery from the solar and still run the electrolyser when there's no sun?
Well, see, again, that ties in with the storage question. So if you wanted to match your electrolyser to your operation, you'd have a bigger electrolyser and no storage, and run your electrolyser and your furnaces and your cars together. If you said, well, I'll buy a smaller electrolyser, I'm still buying green power, and I'll run the smaller electrolyser for 24 hours, you know, you'd have a bit of storage. So again, I think that's part of an examination of, of all of the factors, how much floor space, how much space have you got for equipment, how much have you got for storage, all those sorts of things. So I think that'd be on a sort of a case-by-case basis. Yeah.
I had a question about retrofitting your cremator and how difficult or not the process might be so that you could access this sort of technology.
So what we're doing and what we're spending a lot of effort on in the project that we're doing is to do it in such a way that we don't need to modify existing furnaces. Obviously we're doing it on our own first, but a gas train's a gas train's a gas train. We need to, and without going into sort of too much detail, we've actually, because hydrogen's less dense, we've actually got to be able to get more cubic inches of hydrogen down the pipe, which means we'll have to increase pressures, and it gets to a point where you can't increase the pressures any further in the gas train. So we've got to figure out just how much we can screw up that pressure by, if we put more hydrogen, screw up the pressure more, get more volume down the pipes as to where that finishes. But anecdotally from suppliers of gas valves and stuff like that, we're thinking it's highly likely we can get to at least 30% and possibly 50% without making any changes to existing equipment. And if we can do that, it'd be an absolute winner. Because then we just effectively bolt on a hydrogen gas train next to it, put a T-piece in, and away we go. Chris?
The blended fuel make a cremator more efficient? Is it a hotter flame?
Initially at the low blends, no. At the potentially at 100% hydrogen, your flame temperatures are higher. Your flame temperatures are higher, your flame velocities are higher, so potentially that could make it more efficient. But they're all the things that we want to try. They're all the things that we...
It could also create extra stresses on the inside of the cremator as well, potentially. Are they built for that sort of pressures?
So pressure's not a problem. With the increased velocities, do you get more eroding of the bricks? We don't know.
Will you find out as part of this project?
We will. The flip side of that though, Chris, is if we've got higher velocities, potentially you can, and higher temperatures, potentially your cremation will run quicker. So it might actually end up being, like all things, it might end up being a positive with a couple of little downsides. And obviously part of what we want to do is, because when you get to 100% hydrogen, it needs a new burner. So what does the burner qual look like? And can we optimise that to optimise our cremation? We're reasonably optimistic that we can do that and actually make a better product. One of the other things, without again going into too much detail, the higher flame temperatures give you a higher NOx. So there's a bit of work we've got to do there with nitrous oxides as well. But our main emphasis initially is getting a conversion that can be done without modifying furnaces. That'll give a blend, and it'll get the supply chain established and get everyone comfortable with using this fuel. John, you should run a crematorium, John.
Yeah, I'm fascinated. Yeah, I play with concrete though. I'm fascinated. Everybody talks about emissions, CO2. So what's coming up the flue? Is there any difference in the CO2 emission? Because everybody says that's what's causing the greenhouse effect, that's what's causing the temperature change, that's what's causing the weather change.
Yeah, and certainly, to be clear, I absolutely subscribe to that. There will be an enormous reduction in CO2 coming out of the furnaces, as you get further and closer to 100% hydrogen. The actual body itself, which is carbon, hydrogen, oxygen, will obviously still get carbon dioxide coming from the actual cremation of the body, and you can't change that because we've got carbon in us. But again, if you dig through, that's actually because we're burning the actual body is classified as a renewable organic material, so it actually doesn't go into your accounting, into your carbon accounting. So it's like if you burn a bit of timber out of a plantation, apparently that doesn't count because it's a renewable. It's a renewable. So you've taken the accountable carbon dioxide completely out of the equation when you get to 100%. The geopolymer, no, because there are other sources of fly ash and another source of aluminosilicate slag. and so if we're working with another customer that's doing high temperature gasification, so all of the really horrible plastics and stuff like that that are currently going to landfill that you can't recycle, they've got a really interesting technology where you actually gasify it and then you burn the gases. But his byproduct is actually fly ash. So there are sources like that of fly ash. There are other sources of aluminosilicate, and we've been burning coal for 150 years. We know all the fly ash, where all the fly ash is buried. We have got millions of tonnes of fly ash in the Hunter Valley, in the Latrobe Valley, in South Australia that that we could, with some will, we could actually recover. So there's plenty of sources for that.
It applies for anybody that's opened it up and found it full of water from the customer's experience. Is it permeable to water?
Sorry?
Is it permeable to water?
So it's a look, it's a product like concrete. You can make it you can make it different strengths, more and less permeable. You just need to specify what you want. We've done 1,000 graves at Warrenora Cemetery in Sydney. So there are geopolymer graves in Calliope and Warrenora in Sydney and a couple of other small sites. And they're actually graves, so they're earth at the bottom. But you don't see you don't see wet marks and the formulation we're using sort of coming through the concrete. But you can make it.
What's the cost comparison to steam electricity?
At the minute, again, it's an economies of scale thing. It's about and it depends on whether you're trying to make heavily reinforced stuff or and what strengths and all the rest of it. It's about 20-30% more expensive at the minute, kilogram for kilogram. In some, it's actually got a higher tensile strength, so in some cases you don't need to reinforce it, whereas you would need to reinforce concrete. In that case, it's quite cost competitive.
So concrete beams for headstones.
Yeah. If you drive tractors over them, you need to reinforce it, so it'll be in that 20-30% space. If you don't drive tractors over it, and you can do it unreinforced or just with the particle reinforcing, it's almost getting dollar for dollar.